Hi, this is Lee from the Robby team. In our last video, we used a simple program running the Robby framework to control the treads on my robot named Antwerp, and showed the small amount of code it took to make that happen. At the end of that video, I said I'd show what it took to set up the framework to accomplish controlling the treads in our next video. So that's what we're going to do today. If you saw our first video, you already know how networks are built using the framework's UI, so I won't spend too much time on the details of the software. But I do want to show the specific network I built for running the treads on Antwerp. So let's open up the framework's UI and get to it. You might recall that the framework uses networks made up of channels that pass JSON messages between the devices on the robot and the MCP, or Master Control Program. The structures of the messages are controlled by message schemas, which dictate how information will be shaped when it's passed through the channel. We'll start by looking at how the single channel used by this network is built, so we're going to open up the Channel Builder dialog. The first thing we're going to do is select the channel, which is named the Body Movement Channel. First, let's look at the message schemas used by the channel. For messages going from the MCP out to the Arduino card that controls the motors, we have the body command message schema. You might remember this schema from our last video. I used it in a little program that I used to run the motors. For from device messages, that's messages coming from the Arduino card back to the MCP, we have a very simple schema called body command response schema. Now let's look at the connectors we use. You'll see that we have two connectors for the channel. On the MCP side, we have a very simple string connector which does nothing but pass string messages from the MCP through to the connector to the Arduino card. On the device side, we have the body Arduino connector, which you'll see is a TCP connector. I want to open up the configuration and show you how we configure it for the TCP communication. You can see here that we have both remote and local IP addresses and ports that we're going to use for the TCP communication, as well as a max message size. At the bottom of the dialog, you can see that we have three display gadgets with the channel. These are used in the testing console to display the messages as they pass through the channel. So let's take a look at that right now and open up the testing console. If you saw our first video, you've seen this before. These are the three display gadgets that we saw just a second ago in the channel. And what I'm going to do here is I'm going to open up what's called the MCP simulator dialog. This dialog allows us to pass messages from the MCP to the Arduino card through the channel. So we're going to select the MCP connector to transmit messages to, and now we're going to go and create a schema safe message that we're going to pass out to the Arduino card. You can see that we said we want to pass a capital F out to the Arduino card, which should tell the motors to go in forward direction. And there they go. Now we'll come back here and I'm going to switch it to an X that we're going to send, and this should make the motor stop. Now let's look what was displayed on the testing console when we did that. First, the message would appear here with the F, you can see, for movement direction. Then it's reflected as it goes through the Arduino connector out to the Arduino. And on this one, we see the very simple response that comes back that says received and processed F. So that's how I built and tested the network we used last week in our video when we showed the small program that I wrote actually operating the treads on the robot. You can see I didn't write any code to set up the network. It was all drag and drop and setting simple configurations. In our next video, I'm going to start playing with the ultrasonic range sensors that will be used for collision alerting and avoidance. So we'll be implementing our second channel for the network to add messages coming in from the Arduino card reporting the range sensor values to the MCP twice per second. I'll show you how the framework raises thread-safe events in the MCP when the robot initiates communication with it. So that's it for this video. Thanks very much for watching, and please stay safe and healthy.